Good. So some of you asked me to show you also how to implement our example from the lecture slides on Burnett advertising in Excel. Apparently the video did not help too much, so I'm going to show you how to do it. This is our example. We take the weights method. So we open an Excel sheet. And, look at the mathematical model. We need our objective function, and we need to define the constraints, and also here the deviating variables. The first thing that I will define are the standard variables. We have x1 and x2. And then we have the deviational variables. And there we had S1. Now what I use first? I use first S1 plus, then S1 minus. And to make things a little faster, we need this for all the three constraints. So this is for the first one, that is for the second one, and these are for the third constraint. I'm going to implement just the first version of the problem, so I'm not taking into account the modification here. You can do that on your own when you know how to do the Excel version. So here I define now the left-hand side, and this comes later, and the usual right-hand side. And what I want also to see is the right-hand side plus our deviation, if we have one from the goals. So these are my fields. Then we have 4 constraints together with the budget. So we had the high-income man constraint, the low-income people constraint, and the high-income woman constraint, and then the budget. We need a field for our decision variables that I take here. And this is for all the constraints that we have. I go with my usual scheme. So this one, the left-hand side will be a calculation, and also the right-hand side plus the deviation will be calculated. Now, if you look at the mathematical model, what else do we need? We need the coefficients for the objective function. And I put that one here. It's just for the derivational variables. Okay, so that's it with respect to that part, and now we need the objective as well. And the objective is given by, we see it here, the coefficients multiplied by the derivational variables, those who we want to meet. But for the formula, I can include them all. That is nice if we want to change something in the model with respect to the input data, but we don't want to modify all the time our functions. And that's it so far. What we need for the calculation, well, not everything, but so for the left-hand side, we want to regard the sum product of the input parameters and the respective decision that will be taken. And now I fix these guys here. No. And I can just copy paste the formula. Oops, one too much. So let's check if that worked. Yes, you always want to check your formula if you make a copy-paste mistake, because it would be horrible if that would be why you get the wrong result. So with respect to this, I want to know the right-hand side plus the derivation from my goals. So I define these guys as plus S1 plus and minus S1 minus, and unfortunately there is not a shortcut to do that, so I need to do that one by one. That is good if we just have 3 goals. So the right hand side and their derivations. Now you realize I don't do that for the budget constraint because I didn't include the modification, so we don't have derivational variables for that part. I could leave that open, but just to be comprehensive in the model. So that is the structure that we need so far. Now we look at the coefficients that we need. First, introduce the objective function coefficients. So we don't have one for S plus, but for S minus, none for S plus, but one for S minus, so 1, 2, 3, of course. S3 plus is not regarded, but S minus has a penalty. Okay, and here for the x1 and x2, we just can type the coefficients. And it's 3, 5, 4, and 60. And now, well, here we have the field free, but we can introduce it into Excel by making a 1 or minus 1 with those variables that we want to include. So the S1 plus is with minus 1 and the S1 minus is with plus 1. And because they are the same for the other ones, I just copy and paste that. And you see here also for the budget, I don't include anything. Now this doesn't look too nice, but I want to make it look nice. Okay. What else do we need? This is done. We need the right-hand side. So we have 40, 60, 31, and budget constraint 600,000. And now the next thing that we need to consider is the Excel solver. And we have it under data. So we define where our objective function is for the first thing. It is a minimization problem. The changing variables in yellow. Sorry. And now what we need to give as constraint is that the left-hand side should be equal to the right-hand side, just as we can see in our mathematical model. So this should equal that. Anything else? We could ask the decision variables to be integers, so we get rid of some little some little fractions that might be there, but they are very, very small. We can do it, but it doesn't matter at that stage. We select that the decision variable should be non-negative, and we use the simplex LP to solve the problem. And we have found a solution. We want to keep it. And we see our solution here in the decision variables. Now, exactly what I mentioned with respect to the integer definition of the variable is that here this number is really, 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 really small, so we can consider it 0. But if we want to get rid of that, then and we want we want an integer solution, then we can just define that the decision variables should be integer, and then solve again. And you see that we got rid of this very, very tiny fraction. Yeah, so this is our solution that we have also seen an example.